This is 3.11, related rates, number 37. Fishing. I love fishing, so it's a great problem. An angler hooks a trout and reels in his line at 4 inches per second. I think most of you understand fishing. As he turns the crank here, the line comes in. So the length of this line gets shorter and shorter because you're cranking it in. And so the line is coming in at 4 inches per second. So you have to look at that and realize that is a rate. Something's changing 4 inches every second. It's a change in something over change in something. So we're going to look at that portion. What's changing 4 inches every second? You have to look at this picture and figure out what's changing and label it. So we're going to have something changing as something changes. And I know the bottom's time because seconds is time. What's changing? Now, you could say, I know what's changing. This line from here to here is changing 4 inches per second. That is correct, but that's not going to be your best choice. If I'm going to say this length is changing 4 inches per second, okay? Because it's true, as he winds it in, the length of the red line I have there is changing 4 inches every second. Now, it's also true this whole thing is, but you don't want that whole thing because that messes up your problem, okay? So what do you want to call the length of that? You have freedom to call it whatever you want. Some people might call it L for length or L for line. Some might call it S for string, even though we don't call it string. You get a choice, whatever you want to call that. Some people call it H because it looks like a hypotenuse. I'm going to call it L for fishing line. That's L. So this dl dt is the change in length, 4 inches every second. So this will be 4 inches per second, and that is not correct. Why? So the length of that line, is it getting longer or shorter? It's decreasing. And if it's decreasing, its derivative should be negative, so don't forget the negative there. Now assume the tip of the rod is 12 feet above the water. They gave that to you. It's constant, it doesn't change. It's directly above the angler and the fish is pulled horizontally. So we know the fish is moving to the left. It's not going down or up. It's only moving to the left towards the angler. Find the horizontal speed of the fish when it's 20 feet from the angler. Horizontal speed. They want to know the speed of the fish this way, but what is speed? It's a change in a distance over change in time, right? So let me do this. Find the horizontal speed of the fish. Something's changing as time changes. It's a distance. What distance is changing? I claim it's the distance from there to there. And you got to give that a name. What do you want to call the distance from the fisherman to the fish? Okay, again, you get to choose because they don't tell you. You get the freedom. I know some of you don't like that. You want them to tell you, but on these problems, oftentimes you're just gonna have to pick something. I'm gonna call it F for fish. No, I'm gonna call it T for trout because it's a trout and I like trout. So we're gonna call this T, and that's the distance from there to there. I guess I should clarify L, and that's the distance from there to there. So we want, oh, that's confusing, huh? DT, DT? I don't like that. No more trout. I'm going to call it fishy. The fishy, distance of the fishy away. And they want to know when F is 20. Okay, so all we've done so far is just interpret the English in the picture into calculus. We haven't done anything crazy yet. So now what do? We want an equation that has L and F in it. So if we look at this, we ask ourselves, what equation do we have? I'm going to draw an uncluttered version of this picture. And we know that's 12, we know that's L, and we know that's F. And we know that's a right angle. So you ask yourself, what formula do we have between those three? So our choices were similar triangles, no similar triangles. The other choice was area, volume. There's nothing about area and volume. I could find the area of that triangle, but there's nothing about the rate of the area. So that's no bueno. What was my third one? Oh, Pythagorean theorem. Pythagorean theorem. 12 squared plus f squared is L squared. All right, the one you're going to learn today, there's a fourth one I forgot to tell you about, trig functions. Sometimes you have trig functions. So that's the other one you're going to see. Now let's look, what does this all mean? F is a function of time. It's the length or the distance from the fish to the fisherman, and that changes with time. So that is a function. And L, what's L? L is also a function. It's the length of the fishing line from the tip of the pole to the fish, and that's also changed with time. So both of those are functions, and as we did in chain rule, we box them for our chain rule. Now take the derivative. Derivative of 12 squared is 0 because the derivative of any constant is 0. The derivative of f box squared is 2 times box times derivative of box. And again, the derivative of box squared is 2 times box times the derivative of box. And they want this specifically when f is 20. So let me write that down. When f is 20 inches. Wait, OMG, do we have units issues? Yes, we do. Yes, we do. Did you notice we have different units at different places? Wow, we have to convert everything to the same units. This is inches, and these are feet. Inches, feet. Feet, feet, no bueno. We need to convert them all the same. Wow, I guess we need to do that now? Yeah. So let me back up here. Should I convert everything to feet or everything to inches? That's the question. I think, you know what? I already know we have to convert to inches. We don't, okay, technically you have a choice unless they tell you. Our answer happens to be in inches per second. You could have the inches in feet per second, you'd still be right because they didn't say which way to go. So again, you have to make a choice. We're going to convert everything into inches. So we'll do that on the fly. Okay, divide both sides by 2. Those are gone. And then start substituting things in. Do I know F? Yeah, 20. But it's not 20 inches. It should be converted to feet. So to convert 20 inches to feet, we divide by 12. So again, divide by 12 to convert to feet. Wait, we want to go to inches, don't we? OMG, my brain. Let me read the problem again. We want to have our answer in inches. I went the wrong way. My apologies. So what was 20? I am not labeling things clearly. That's feet. 20 is feet. These are feet. These are, wow, I am so bad. These are feet. When F is 20 feet, I need to convert 20 feet into inches. So 20 feet equals 20 times 12 inches, which is 240 inches. Okay, are we good at that? So we're going to have 240 inches. That's F. df dt is what we're looking for. So I'm going to leave that as df dt when F is 20 feet. L, OMG, what's L? Okay, I have to do some fancy footwork here. When F is 20, what's L? Pythagorean theorem, right? L is the square root of 12 squared plus 20 squared. But that's in feet. To convert that to inches, I have to multiply that by 12. So L is going to be 12 squared plus 20 squared times 12, and that will convert it to inches. So I am going to run out of room. Okay, here's what I'm going to do. I'm going to put that in the calculator and get an approximation because I am running out of room. Let me do this. 12 squared plus 20 squared. I want the square root of that. I want times by 12. So that's going to be 279.885691. So to save myself some space, this number goes here for L, right? And then what's the LDT? The LDT is given -4 inches per second. All right, all this work. So I'm going to have 279.885691 times -4 inches per second. And this is inches. Wow, you know what? I need space. I can't breathe. Space. I'm going to move things around. So this is inches. And then -4 inches per second. And then I have to divide by 240, right? All divided by 240 inches. So unit cancellation, those cancel with those. And now I just multiply and divide. So I'm going to take my answer, times that by -4, and divide by 240 on my calculator. And hopefully this answer is right. This answer is going to come out be -4.665 inches per second. Let me read the answer. Okay, that means it's decreasing. F is decreasing, and we know that's happening because she's reeling in the fish. 4.66, is that what I got? Yes. Yes. My answer matches. They truncated and didn't round off. That's very interesting. No. I round off. Okay, never mind. Our answers are the same. I just went one extra place. That was 6647, so round off to 5. All right, craziness. That is craziness. Good news, you will see the ones that on an AP test are not that complicated.